In 2011, Tiangong space station was planned to be assembled during 2022. By 2013, the space station's core module was planned to be launched earlier, in 2018, followed by the first laboratory module in 2020 and a second in 2022. By 2018, this had slipped to 2020 to 2023. A total of 12 launches are planned for the whole construction phase, now beginning in 2021. The name of this space station is Tiangong Space Station, meaning Heavenly Palace. It is placed in low Earth orbit between 340 and 450 km, that is 210 and 280 miles. Operations will be controlled from Beijing Aerospace Flight Control Center in China. The core module, the Tianhe, meaning Harmony of the Heavens, launched on 29th April 2021 by the manufacturer China National Space Administration. Other two modules such as Wentian and Mengtian are expected to be launched in 2022. Here, Tianhe is the core cabin module, also called as CCM, and Wentian and Mengtian are laboratory cabin modules, also known as LCM. Everything is launched from the same launchpad, the Wenchang spacecraft launch site. The construction of this station marks the third phase of the Tiangong programs, building on the experience gained from its predecessors Tiangong 1 and Tiangong 2. A Long March 2F with a Shenzhou spacecraft will always be on standby for an emergency rescue mission. There are some sources which claims that this space station has a space telescope module that would be called Thnk. According to China Manned Space Engineering Office, the purpose and mission of Tiangong space station is listed as further development of spacecraft readiness technology, breakthrough in key technologies such as permanent human operations in orbit, long-term autonomous spaceflight of the space station, regenerative life support technology, and autonomous cargo and fuel supply technology, test of next-generation orbit transportation vehicles, scientific and practical applications at a large scale in orbit, development of technology that can aid future deep space exploration. Electrical power is provided by two steerable solar power arrays on each module, which use gallium arsenide photovoltaic cells to convert sunlight into electricity. Energy is stored to power the station when it passes into the Earth's shadow. Resupply spacecraft will replenish fuel for the station's propulsion engines for station keeping to counter the effects of atmospheric drag. The solar arrays are designed to last up to 15 years. Tiangong station is equipped with Wi-Fi network for wireless connection, and each astronaut wears bone conduction headphone and microphone to facilitate easier communication. 120 different types of plates, which are selected based on astronauts' preference, are stored on the Tiangong station. Stable food including shredded pork in garlic sauce, Kwang Pao chicken, black pepper beef, pickled garbage, and beverages including variety of teas and juices were carried by Tianzhou 2 cargo ship. Fresh fruits and vegetables are stored in coolers. Hong Wei-fen, chief astronaut trainer of CNSA, explains that most of the food are prepared to be in solid, boneless, and small pieces. Condiments such as pork sauce and Sichuan pepper sauce are provided to combat temporary loss of sense of taste experienced in microgravity. The space station is also equipped with a small kitchen for food preparation and the first ever microwave oven in spaceflight application, so that astronauts can always have hot food whenever they need. The Tianhe core cabin module provides life support and living quarters for 3 crew members and provides guidance, navigation, and orientation control for the station. The module also provides the station's power, propulsion, and life support systems. The module consists of 3 sections: living quarters, service section, and a docking hub. The living quarters will contain a kitchen and toilet, fire control equipment, atmospheric processing and control equipment, computers, scientific apparatus, communications, equipment to send and receive communications via ground in Beijing and other equipment. A Canadian-style SSRMS robotic arm will be transported into space folded under the Tianzhen service section. Additionally, the Ventian experiment will also carry a duplicate stored second SSRMS robotic arm. In 2018, full-scale mock-up of core cabin module was publicly presented at China International Aviation and Aerospace Exhibition in Zhuhai. The video from CNSA revealed that the Chinese have built two of these core modules. Artist impressions have also depicted the two core modules docked together to enlarge the overall station. The first two laboratory cabin modules, Ventian and Mentian respectively, will provide additional navigation avionics, propulsion and orientation control as backup functions for the CCM. Both LCMs will provide a pressurized environment for researchers to conduct science experiments in freefall or microgravity, which could not be conducted on Earth for more than a few minutes. Experiments can also be placed on the outside of the modules for exposure to the space environment, cosmic rays, vacuum, and solar wind. Like MIR and the Russian orbital segment of the ISS, the Tiangong modules will be carried fully assembled into orbit, in contrast to the US orbital segment of the ISS, which required spacewalking to interconnect cables, piping, and structural elements manually. The axial port of the LCMs will be fitted with reduced equipment and will first dock to the axial port of the CCM. A mechanical arm similar to the Russian Lepa arm used on the Mir space station will then move the module to radial port of the CCM. In addition to the Lepa arm used for docking relocation, a 10 meters long robotic arm for exterior station operations is also mounted on the Thnk module. The Chinese Large Modular Space Station is designed to be used for 10 years, which could be extended to 15 years and will accommodate 3 astronauts. Chinese crewed spacecraft use deorbital burns to slow their velocity, resulting in their re-entry to the Earth's atmosphere. Vehicles carrying a crew have a heat shield which prevents the vehicle's destruction caused by aerodynamic heating upon contact with the Earth's atmosphere. The CSS has no heat shield. However, small parts of the space station can reach the surface of the Earth, so uninhabited areas will be targeted for deorbit maneuvers. Hey guys, that's all for today. If you liked this video, please make sure you subscribe to our Horizon Cosmos channel, and if you need any content, please ask in the comment section and we will try to upload as soon as possible. Thank you for watching our video guys. See you later.